today we have Thomas Kurian, along with our moderator, Frederic Lardenois. Please welcome them to the stage.
All right, full house. We just spent 20 minutes talking about soccer and cricket, so got to switch up the conversation a little bit here. When you joined Google Cloud in 2019, you and I sat down at some point at Google Next, and we talked about Kubernetes and multi-cloud and kind of infrastructure things and servers. The world has changed quite a bit since then. And I was at Google Cloud Next a few weeks ago, and I was joking, we should just call it Google AI Next. At what point did you realize that AI was going to be the next big thing for you?
Probably as far back as 2020. You know, our vision for cloud computing has always been super simple. It's been about simplifying technology so that people can use it to build great applications. The first problem we solved was using cloud to deliver infrastructure. Instead of having to have people buy data center space and machines and manage them, we said we can just give you infrastructure as a service. Then we built managed services on top of it so that if you had challenges getting access to people, for example, to manage a database or to do cybersecurity or to build collaboration tools, we could give it to you as a fully managed service. So when AI came along, we started our work at Google back, almost 20 years ago on AI. And we saw that the application of AI into applications, whether it was search or YouTube or Gmail, was the central way that people were going to experience AI. And so we felt that if we can give people a platform, one, where they can either develop applications using models extremely easily, and where the platform would simplify how they used AI, or for end users, where our products themselves incorporated AI to represent all the skills they needed, it would hugely transform the way they experienced AI. And so there have been many, many moments on that journey, but we've been working on it now for almost 4 years.
And when you talk about AI right now, are you talking about generative AI already at that point, or are we more thinking about the machine learning as we used to call it back then?
We've worked through 4 evolutions of AI. The first version of AI was what we were doing called classification. Classification, for those of you who use Google Search, if you go and type into search and say, find me an image of a cat, it returns an image of a cat and not a dog because it's doing classification. If you then say, find me an image of a cat in my drive, but you don't have image of a cat in your drive, but it returns image of an animal and not a plant, it's doing something called categorization. The third flavor that we brought out was prediction. Prediction is, hey, I am managing supply chain or inventory or demand picture. Tell me how my inventory is going to look like if trends continue like this or if they change. And that's using statistical methods or what we call Bayesian models to do prediction. And then generation is where you train a model on a set of data, and then the model can generate output based on the data it was trained on. And so those are multimodal models where you can talk to it using either chat or text, and it can respond in text, chat, it can generate code, it can generate images, audio, video, and different modalities. So for us, this is our 4th generation. Many of you use our products, like for example, if you use Gmail, we're helping you write. And we're helping you write at scale. We use underneath, when you say you get suggestions like autocomplete something for me or type in things, we do that 180 billion times a year, which is 500,000 times a day, 500 million times a day, 500 million times a day. And so we've been using AI inside our products from as early as 2014. So that's a lot of history in how we built AI models, but also brought it to people.
Was there a moment for you when you first saw a demo of generative AI where you said, yes, this is something we have to go all in on?
There were many different applications which we saw were truly, transformative. One of our teams, for example, we run many of the largest contact centers in the world. And contact centers are fairly sophisticated in the sense of the number of different types of questions you get and how sophisticated your understanding of a user's intent and being able to respond to it. One of our teams has built a model which is actually being used by many companies now to understand questions. And we had an organization provided 1 billion user inputs, meaning there's potentially 1 billion different combinations of questions that could come in. And the model was remarkably accurate in responding. And that's when you have the moment that a normal person would have a hard time remembering 1 billion combinations and being able to handle all of them. And here's a model that's handling a very, very sophisticated set of questions and being able to do it with remarkable fidelity.
Most people can handle. No, just kidding. So, let me talk business for a second here, because when you took over Google Cloud was kind of the number 3 cloud. You still are.
Yeah.
When you think of AI now, is that a moment for you to kind of reset this game?
Just if you look at our growth, when I joined Google, our cloud business was the 28th largest software company in the world. Today, we are 3rd in cloud, but we are the 5th largest software company in the world. There are only 4 others larger than us, and they were all founded before the year 2000. So in 4 years, we've created one of the 5 largest software companies in the world. We look at our growth rate as a metric of our success. A big part of it has been finding the problem that customers are going to want to solve and being able to solve it better than anybody else. So when we look at AI, we saw people wanting to have 4 capabilities. One is really world-class infrastructure for training and serving models. And the kind of systems that you can give people to be able to train models faster and cheaper, and also to inference. We today run 50% of all AI startups in the world, and we run 70% of all the AI unicorns. And so the companies that really know the technical detail of what is needed to serve and to train and serve models choose us because we have the most optimized infrastructure. So that was one. The second thing we saw is that companies founding on AI, particularly those that want people to use them at scale, you need a set of services around the model itself. And so we built a platform, and through that platform, we make models available, not just our models, Google models, but also models from third parties and startups. But we surround them with a number of capabilities that people need if they're going to build applications. Take a practical matter. Models are known to hallucinate, meaning they answer, and the answer may not be factual. So how do you make sure you check and look at where the model derived the answer from? That's called grounding. We have services for grounding, for watermarking, for responsibility controls, for synthetic data generation, reinforcement learning, feedback automation. Remember, Google invented most of these things. All the things that we use in our search, in our YouTube and other platforms, the technology that engineers use when we use models internally, we're exposing through our platform for developers so that you get the benefits of all of that. So that's number 2. And the third thing we've always felt is models are evolving on a multi-year journey to do all the skills that humans have. And so when we look at that, the idea we had with models was to take each role that people had and have a model augment it. So for instance, if you're a software engineer at Google, you can use a model to write code. You can use a model to generate the documentation for the code. You can have the model do code inspection, which is I submit code before I'm allowed to check in. I'm going to have the model actually inspect my code to make sure I don't have a security vulnerability in my code, for example. You can have the model generate tests. I know engineers love to write tests, right? Nobody likes to write tests. So the model can generate unit tests. And so this is an example of something that we built. Our people are using at scale, but we're also making available to other companies now so that you can have an expert pair programmer work alongside you. And so when we looked at AI, we felt some people will want amazingly cost-effective, scalable infrastructure to train their models on. Some people will want a platform where they've already built a model, but they want to reach developers through the platform. That's the second piece. And the third piece is some people will want to use models to build solutions for end users. And one type of profile is what we're doing for programmers, but we're building these end user profile solutions for a variety of other users as well.
So I want to talk about the open ecosystem and programming for a moment. But to get back to business for a second, do you think AI is going to be the main driver of growth for you?
You know, we're seeing growth. You can't grow from where we were to one of the 5 largest companies just depending on one driver. We do think AI will infuse a lot of our solutions. And just to give you an example, we've taken every part of our portfolio and built an AI-powered experience for people. So think of, I'll just give you 2 examples. If you use our collaboration tool, we took each persona in the collaboration tool and built an AI-powered experience. So if you're using our document authoring tool, Google Docs, we can actually help you write, and an author can assist you writing. If you're people who love to do slides, but you don't know how to do graphics very well, you can actually type in text, and we can generate the graphics for you. Many advertising agencies are using it to actually build ad campaigns. So we took each of the profiles. If you attend video conferences, I know all of you love to do video conferences. And if you want to have a person who can transcribe the meeting, summarize the action items of the meeting, generate a summary of the meeting, translate the summary into all the languages because many people are working across different countries, you can do that automatically. So we've taken each of the personas that people typically want because they say, I wish I had an administrative assistant who could take meeting notes, and now we've built it with AI. It's the same thing for using our platform. If you're a developer who wants to access our platform, you can go in and say, take as a very simple example, many people have to do data analysis. And they get questions all the time, what are the numbers? How are our numbers doing? So we wanted to simplify it. So we said, you can go into a search box and say, tell me how revenue is trending. The system will, 1, calculate your revenue trend. 2, it'll tell you why revenue is trending that way. 3rd, it'll generate a narration. 4th, it'll build a chart. 5th, it'll create the slide deck. And it'll write the slide deck for you. That's what is available now. And so a lot of what we've done with AI is to take AI and infuse it into all the tasks that people want to do to make it so much easier to get them done. And by doing that, we want to be able to open up technology for more people. Because the easier you make it, the more people then get access to it.
And you've brought up Workspace quite a bit now, you know, the consumer office suite side of Google Cloud. I'm not sure everybody's aware that those all fall under your regime, but did you ever think of splitting those two up, and did kind of this AI revolution change that discussion in any way?
So Workspace, for those of you who use Gmail or Google Docs, we offer an enterprise version of that called Workspace. It's used by over 10 million companies around the world and government agencies and other people. What we're really trying to do with it is twofold. One, to make the experience of using it. If you think about what email systems, word processors, et cetera, were, a word processor for the last 30 years was just a replacement for the typewriter. A spreadsheet was a replacement of a calculator. A slide deck was a replacement for what people used to do called slide projector. We felt that with AI, you should be able to do more. We should make the word processor an author to help you write. We should make the spreadsheet an analyst that will help you calculate. We should take the slide projector and replace it with a digital graphics artist, an AI-powered graphics artist, that you can collaborate in real time, and that's why we call it duet, because you are working with somebody, a digital somebody, in real time. And it can assist you in doing tasks that you couldn't do yourself. Now, we've integrated that into the Google Cloud Platform because many developers say, hey, I'm working on a project. I want to chat with somebody to get some help. I'm working on a project. I want to generate the documentation for my application, and I'd like to use the document authoring facility to generate the documentation for my project. So we've integrated and made it extremely easy for people to use these pieces together. And AI brings all the skills that you need into one system so people can do it.
The thing with AI is that it's expensive to run, and you've got these consumer services that are being used by billions of users. Is AI going to be one of the main differentiators in between the enterprise versions and the consumer versions, where the enterprise version will have more sophisticated features in Gmail and Docs, or how are you thinking about that?
So the models that we use today, if you go to Google Search, we have something called Search Generative Experience, which is our new generative AI-powered search experience. The models that sit under search, we're making available to everybody. So every model that we use internally, we're making available to customers as well to build their applications, and we're making it available at the very same time as we're doing internally. Now, to make models work well, we've been very clear, based on our own experience, that you want to choose the right model for the task. And when I say the right model, models can be of different sizes. The largest model is not always the right one. Let me give you an example. Imagine you're a software engineer and you're writing code. If you want to generate a function, you say, please generate this function, and you wait. If you're typing code and you want it to auto-complete, you want that code fragment that you're auto-completing to happen in real time, because otherwise you type and then you're typing over something the model is generating. So the smaller models have better latency. They can be lower cost. They can also answer many questions that you may not need the larger model to solve for. So most clients that we work with, we actually allow them to use a combination of models. So you can start, for example, talking to the smaller model. If it can't answer the question, it can transparently fall back to the larger model. And for those of you who use Gmail, you can actually see it in the preview that we're running right now for customers. So you can, for example, on your iOS and Android device, you can bring up the Gmail app if you're part of our preview, and you can say, help me write. It talks to a model that's running on the phone. You can imagine that's a highly compressed, highly distilled model. The reason we're doing it on the phone is both to make latency low, and if you're in a place that you don't have great connectivity, you can still write. If you want the model to do more sophisticated things, it can fall back transparently to a larger model that runs in our cloud. And so we're trying to give people the choice of the best model, which can be a combination of size, cost, latency, and a variety of other characteristics.
But just to go back to the question, does that mean the free user won't get that choice and will get the smaller model, or what is that going to look like?
There is a set of features that are generative that we made available generally in Gmail to everybody. We have not yet announced consumer because we're still testing with consumers. We're also testing in different languages, because we've got a large user base outside the United States. We've said publicly that we will be making the product available to consumers, very small businesses, and large enterprises. And there'll be a set of capability that we just include in the product.
All right, let's go back to the models for a second there again, because when I was at Google Cloud Next a few weeks ago, this open ecosystem of models was something you were highlighting quite a bit. And that means you're working with some, not competitors, but other, like Facebook, for example, with the Llama models, which is somewhat unusual, right? But why is that open ecosystem so important to you?
So we work with 3 types of models. Obviously, people ask, can I get Google's latest models? Yes. And as I said, the same models that sit under our consumer properties are available at the same time as they're available inside the consumer properties. We also work with a variety of open source models. Open source models like Stable Diffusion, Llama 2, Code Llama, Falcon, there's a variety of them. The way we do it is we actually poll our developer community to see what they really want us to work with. And the popular ones, we actually package in a PyTorch container and make that available for people. So that's number 2. Number 3, there are some companies that work with third-party models. Third-party models are not open source models, but third-party models, like Claude, for example, from Anthropic. We do support Claude. We do support Cohere. AI21 Labs is available. Runway, which is a super popular media, video model, is available. We work with Midjourney. So we want to allow customers to choose the best one. In some cases, the best one will be from Google. In some cases, the best one may be from somebody else. And we offer you one platform where you can use all of it so that you don't have to choose different tools every time you want to choose a different model.
And that's somewhat different from some of your competitors. Do you think that's a major differentiator for you? Is that part of why you're doing this?
We definitely feel that customers should choose a platform to build with AI. And we always tell customers, if you look at the large companies we work with, whether that's Wendy's or Priceline, or we've had hundreds of customers do announcements with us, Mayo Clinic and others, they're deploying it across a range of different environments. And we always tell them the most important thing is you need to choose a platform that provides you the ability to manage models, test them, evaluate them, handle change management, all this stuff. And so when we did that, people said, can you allow me to use a range of models, not just yours, with the platform? And we felt that was the right thing.
Run those models and run them on Google Cloud.
You can run those models super efficiently because they're getting the infrastructure to run that we're using to run our search models, our Gmail models. So you can imagine we've spent years optimizing performance and cost to serve those models extremely cost effectively. We're making that available to third parties to use to serve their models to the developer ecosystem just as cost efficiently as our models.
And talking about that infrastructure, a lot of the industry is suffering from just not being able to get the GPUs and the chips they want. Is that a problem you're facing as well?
We've seen the evolution of infrastructure for many years. And as AI moves from the realm of data science and research into applications, you actually need a range of different kinds of accelerators. So as an example, if you train a model, depending on if you're building a sparse model or a dense model, if you're using something called mixture of experts versus a single large model, the kind of chips and system you need are very different. because you need to decide how much coalesced memory do you need versus how much memory per chip do you need, etc. Same thing for serving. There are many, many techniques now being used when you serve a model. For example, if you've got data in a data store, people use something called vectorization to expose it. Depending on how much is textual versus numbers, you may decide how much floating point optimization you need. So what we have seen at Google, because we're in our 10th year of building ML systems, is you will need a range of these different kinds. And so we offer 13 different kinds of accelerators so that people can choose the one that's really optimized for their needs. Part of the value of that is we're not bottlenecked on the supply chain constraint. Right now, the supply chain constraint is around a manufacturing process called chip on wafer on substrate. Many accelerators don't have that bottleneck. And because we offer the diversity, we don't have the same constraints in offering people the ability to use this infrastructure.
You said earlier on your constraint is more in the number of people you have that can install those chips in your data centers.
Obviously, we've not yet built a system where a chip just walks into the data center and plugs itself in, right? So there's lots of logistical work we have going on to get the machines in. We use water cooling for some of our larger systems because they really provide a materially better performance and cost of training. So there are many, many people at Google working on making sure that part of the ecosystem works well.
All right, well, we'll head out and install some H100s somewhere in a data center. Thank you very much.
Thank you all.
Thank you.